There's a lot of conversation right now about turbo or turbo motors and whether or not they have the same sort of quality or durability, and that's not lost on us. Our reputation has been staked on quality, dependability, and reliability. We say that all the time, and I know people start to get a little bit tired of hearing it, but it is our mantra, it's our ethos. Just an example, and I don't know that a lot of people know this, but we're using like a 70 millimeter or so, a 3-inch pump to move the water on the L4. That's something that we would have traditionally put on a V8.
There are a couple of products that define Toyota.
Sure.
You could say Camry, you could say Corolla. I would argue Tacoma, Hilux, whatever the hell you want to call it, that's one of the most important products and pays the bills. What were you doing before you got to Tacoma?
The great part about the Toyota lineup is there's a lot of all-stars along the whole, I'll say, batting order. But to your point, especially within North America, Tacoma, it carries a lot of water for us, and it's a somewhat iconic truck. And as a result of that, it was really important that we put our best foot forward. So my pedigree kind of started, we were working on North American product when I started 28 years ago. A lot of that was like Avalons and Camrys and Siennas, because that's a lot of what we developed and we produced here. And it made sense, especially with the volumes that you talked about on some of those particular products, and the fact that they were very North American unique. It made a lot of sense to do that. So I sort of cut my teeth through that in I'll say in the engineering world, body engineering mostly. Worked a lot in the interior side. And then I moved over to the product development. But most recently, I had worked in some of the electrification projects early. We did a joint venture with Tesla, RAV4 EV, and I was working on that. And then I moved over and was working on the proof of concept. You may have seen it before. It's called the Portal Project. We did that from probably 2016 or 2015 to 2017. And that was really proving that in a Class 8 diesel rig, we could take the fundamental underpinnings of our Mirai fuel cell system, and basically with an upscaled battery and some significantly larger tanks, using those fuel cells to power that. And so we announced that to the world in 2017, and shortly after that, I was asked to come back to the vehicle planning side and work on Tacoma.
And so give me an idea, when did development of this new generation of Tacoma start in earnest?
Back in roughly, say, 2018 timeframe, there was a lot of emphasis on what this next generation platform was going to look like. Obviously, we were going to roll, Land Cruiser was going to be the first vehicle to roll out on this platform. But when you're doing that platform planning, including the powertrain lineups, you need to be looking far into the future. So we had to have a solution that was going to work for the full size and for example, for global Land Cruiser, but also is going to have the ability to roll down across to trucks like Tacoma in the mid-size segment. While we are really focusing on the full-size development, we are still thinking about, does the plan work for Tacoma? And then, we were in the middle of the minor change at that time, which we launched in 2020, and the outgoing product. So we were sort of working on that, while at the same time we were beginning to build the concept. So I would tell you at end of 2018 time-ish, right around there, we were really working on what did we want this next generation Tacoma to be, so that as we continue to develop and progress the platform, we could make sure, we said, please make sure that we can accommodate such and such, or we are going to need this in the compact segment. Because when we looked at the trucks as brothers, we wanted to think about the entire truck market. We basically have two products, the Tacoma and the Tundra and the pickup truck, that need to cover this broad range. And so there were going to be attributes that were going to be unique, and the purpose of what the Tundra was to do, and then there was going to be other attributes that Tacoma was meant to excel in.
Give me three specific examples that differentiate those aspects between a Tundra and a Tacoma.
So first and foremost, full size, it's a premium towing machine. It was going to tow, and it was going to tow extraordinarily well. That's important in the full-size pickup segment. In the mid-size, it's important to tow, and again, we want to tow well. We're not going to chase catalog numbers, but it's not our priority. We surveyed our customers. We find that very few of our customers tow on a regular basis, tow anything above 6,000 pounds. So we made sure that we set our targets higher than that, but we weren't going to go chasing huge numbers, and so that's a really important one. When we talked about the suspension, Tundra, because of towing and because of load carrying and being a bit more of a family hauler, we really focused on, and I think Mike focused on, stability. And so that was really making sure that we had a very wide platform, and that platform and that stance of the vehicle was really about that sort of inline stability. And Tacoma, we certainly want to have that, but we focused on suspension articulation. and making sure that we are more capable in those off-road areas. So in this particular area, if we think about sort of off-road duty or capability, we sort of, and this is a little bit of internal ranking, but as we try to collectively think about how to prioritize these, we'll have like a off-road, then we have like medium duty, high duty, and then we have like, you know, Land Cruiser. And then we wanted to think about, again, the value to our customer. Both trucks need to provide that, but the compact segment is significantly more sensitive to the price, perhaps, in the full size.
Value is money. It's not so much how much equipment can we put at a standard price.
Well, it's a little bit of both, right? Because there's a minimum entry that you need to provide, but you have to do it in a way that provides a good product, and you're not just taking things from the customer, but there's value engineering that goes into this to say we're going to give you a very serviceable vehicle, but we recognize that your budget is lower, for example, than maybe in a full-size truck. So do they overlap? Of course, they're going to overlap between compact and full-size, but really focusing on that entry level was really important for the compact truck.
So you, if I'm getting this right, you started about 2018 on this.
Yeah.
The world obviously changed in 2020.
It did.
A lot of, not just Toyota, but every car manufacturer, price points changed.
They sure
and
did.
dictated by supplies, all sorts of stuff. Was there a discussion at some point saying, okay, our truck, what was it, high 20s was the basic car in the outgoing truck. Was there a discussion in 2021, like, oh my God, can we even hit the high 20s, or are we going to let it float up to, say, 30-something based on what the market's done? We
have an exercise internally where we take a look at what is the cost of the existing product. Okay, and then we talk about where we're expanding and we're adding some additional value. But we use this, we try to isolate ourselves from economics, because what we're focusing on is, can we develop the same truck more efficiently and more cost effectively? So don't worry about what the price of oil is doing today. We're not going to be at the end of the road, and we can't predict that per se. But what we can focus on is making sure on a comparative basis that we're bringing additional value or reducing cost, and that we're using new technologies to supplement.
Give me 3 examples of that in this new Tacoma.
Yeah, sure. So in the new Tacoma, really there's a couple of different areas where we look at, I'll say, big cost reduction areas. One of those, and I think we might talk about it later, is the need to have across our entire lineup was the coil suspension. It is fantastic. It makes the ride and handling and performance great. A lot of folks say, I got no problem with my current truck, and it has a leaf, and I'm perfectly happy with that. And so as a person who's very value focused, we said, can we rethink F1 a little bit and maybe make a modification and do that in a way that's clever, that we can basically bring some of that cost out of the suspension underpinnings and pass that along to the customer. That was a really important one. And then other areas, we looked at, okay, the truck is going to get a little bit bigger. The truck might tend to weigh more, but we need to make sure that we're keeping it in that same sort of, I'll say, inertial weight class. And so that's where we started to look at new materials, and where can we bring new materials in efficiently that can help us reduce help us reduce mass without, prolifically driving cost. And so that was another approach that we wanted to take, again, keeping value in it, making sure that in the areas where we specified alternative materials, there's a customer-facing value to that. So it might have helped us with mass, but it also allowed us, for example, to increase payload, for example. So that way we can pass that value back on to the customer. Those were sort of the tenets of how we overall approach this. And then there's other areas where we looked across the brothers and we said, what if we can reduce the development cost? What if we can expand the volume by sharing some of these common technologies? There might be tweaks here and there to make them, I'll say, more suited to each of the different brothers, but the core underpinnings are the same. We're sharing that value, and then by doing that, again, we can reduce our development costs, we can reduce our supplier tooling, we can reduce even our overall piece price. And that's things that we can do to pass on good value to the customer. So you're getting more value, you're getting better performance, and we're able to rein in the sort of skyrocketing cost, if you will.
So let's go back to the mass thing.
Sure.
And this is, I think, a global discussion.
It is.
And I'll kick this off with a bit of a story. My father has a 56 Chevy. Okay. People look at those things and say, oh my God, big car, big old heavy car. They don't make cars like they used to. Mm-hmm. That car weighs 3,200 pounds.
Sure.
Okay, some track cars today, fast track cars, are 3,200 pounds.
Sure.
Yet I'm driving crossovers that you guys make that are 4,600 pounds. That's kind of like the norm now.
Sure.
What is considered the range that's acceptable when you go into a project? I'm not saying at the end of the rainbow, but like, what can we accept? 42 to 4,800, over 5,000? Because it's changed over the past 10 years.
It has, but I think the other things that the other piece that you need to bring into that is the overall safety performance of those vehicles. I would take head to head, the
I get that governments are starting to not starting to, they've had a lot of impact on, they've become engineers like you.
Sure.
They just don't know as much as you.
And beyond government, though, it's also a third party rating, and it's also, we are looking to continually, as we see, vehicle, accidents are increasing, we see driver distraction, things of that nature. The first goal is prevent it, right? But the second goal, of course, is to, if indeed the worst happens, let's make sure that we're protecting our occupants. So I think, though, in terms of durability, and I think in terms of overall strength and performance, those aren't even this. You're getting superior performance without a huge difference in the overall mass. But like any vehicle project, we start off and we talk about what our platform needs to be, and then we call something we call cover range, which is the lightest to the heaviest, and then we have to balance that with our powertrain lineup, because mass, when we think about like CAFE performance and we think about fuel efficiency and emissions performance, mass is an enemy of ours, right? It makes everything heavier, it makes it harder to move, it means we have to get more power that has to come out of our powertrain, which means it becomes less efficient. So reducing the mass is a tenet, is a core tenet of all automakers, really probably all manufacturers, to try to remove that, because it's less material, because it means better overall performance. And so as we focus on that, we do set targets for each of those, and those are dependent on this whole entire vehicle architecture.
Okay, so let's be very clear about this. You've been doing this, you said 28 years.
20 years, yes, sir.
Doesn't look a day over 26 years. You've been doing 28 years.
Yeah.
What was that number 28 years ago, and what is that number today?
And I won't even go back quite that far, because again, there are so many factors that get into the capability of the truck, the performance of the truck, the safety standards, the strength, etc. But just look at the outgoing to the next generation truck. Obviously, we talked about the wheelbase on this truck has gotten longer and has gotten wider, right? That means our big heavy parts, things like drive lines, axles, things of that, they're getting by definition bigger. So the wheelbase moved about 4.5 inches compared. It is. It's significant. And then when we think about an SR5 to an SR5, you're seeing about a 3-inch width change in the track width. That is great for our stability, right? I mean, and then of course some of our vehicle dynamics is really helpful. And to be, completely transparent, that's also, the part of how we track our CAFE is based on that overall footprint as well. And we're basically, within say 50 pounds, we're the same truck.
You're also adding an electric motor and a battery in some cases.
We are doing that. When you bring the whole system together, again, those also come in some of our higher spec vehicles, so you got to kind of balance those out. But yeah, we jump up a couple of inertia classes when we move to the one motor, to the iForce Max, what we would call the Toyota hybrid system. That would be what is people think about it, our traditional two-motor hybrid system. That is hyper focused on efficiency. And the one motor is a little bit of a balance. It's really focused on power, torque, and still providing efficiency. So we had a lot of customers say, when are you going to put a V8? When are you going to put the 5.7 into the Tacoma? And in just today's real world, we can't do that. We'd never meet the performance requirements for fuel economy. We wouldn't be competitive. We wouldn't do very well in emissions performance either. And so what we're able to do, though, is to take an L4, pair that with an 8-speed transmission and a one motor. We'll sandwich in between those. And with this MG motor, we're able to provide us instantaneous torque. So we can fill any of that area where there's this, and I would say very slight turbo lag. And then, of course, we can continue to support that through the course of the drive cycle. And what that does is just, really harnesses that power of electrification and that inherently instantaneous torque. And then that's where the motor really shines. And we do that. And so then we give you V8 horsepower, V8 torque, and we give you, L4 fuel economy. And the incredible part is incredible emissions performance, right? So it's really, we give you all that, and we give you better performance across the board. Used to be we gave you horsepower, but we took efficiency away from you.
So along those lines, and I'm not going to win any friends with the audience, I would think you can get the torque and the horsepower of a V8 out of the system you have now. But let's say, for the sake of discussion, there are those folks that I got to have me a 392 Wrangler, or I got to have me a Raptor R, or whatever they call it. Is it possible to be even develop a V8 in a Tacoma and make it something completely stupid and have people pay $100,000 like they're paying for a 392 Wrangler?
Technically, anything's possible. And can we do it? Sure. At the moment, I would tell you that the market audience, while it sounds sexy on paper, the market is pretty small for something like that. Not to say that there aren't enthusiasts all over the world, but we're not going to sell. We probably wouldn't sell tens of thousands of them. And right now, I think there is a focused effort is the task that we're seeing at hand, which is improvement of the overall CAFE performance in the fleet, reduction of GHG greenhouse gases. And so our energies right now as a company are focused on making sure that we're providing solid, affordable solutions to our customers that help them have better efficiency at the pump, or better efficiency at their home or wherever they happen to be charging, and also that are contributing to the overall target, which is this greenhouse gas reduction. Toyota has been way ahead of this game. We've been producing hybrids long before it was socially cool.
You guys are like grandparents in this industry at this point.
And I think that we're still committed to hybrid. We're committed to plug-in hybrid and fuel cell, as well as battery electrification. Sometimes you get a bad rap and say, well, you're not running as fast to everybody. We just don't necessarily believe that that batteries are the silver bullet solution. We believe it's a more I'll say broader range, sort of multi-technology solution that provides the solution that you need, right? While one solution might work great for the West Coast in California, where we have temperate climates and a lot of energy production that's coming from geothermal or through hydro, for example, hydroelectric, that may not be the same solution that's great for maybe the Midwest or the center of the country as well. And now you take that and you apply that across a global platform. We think this sort of multi-solution approach is a better way to get there faster and more efficiently.
My audience knows this about me. I am one of the few people that feels your strategic direction is the smarter one. And I'll tell you why. I'm firmly convinced that Brussels and Washington and Ottawa, if you want to throw it in there as well, they will have to back off some of these mandates when they realize they aren't achievable in the timescales. In 30 years, yes, but in 13, what is it now? No, excuse me, 12 years, where it's got to be all battery electric, it's highly unrealistic. And that's where I look at a company like you guys, where you're playing into the mandates a little bit, but you have this electrification strategy, meaning not just electric. And when the mandates kind of roll back, you guys will be ready. Won't have to keyhole the whole system. Is that part of the strategy here when someone comes to you and says, okay, we're going to do a hybrid version or a one-motor solution? Or is it something that you're just looking at the performance versus efficiency benefit there? My
job is to provide the technology that is compliant with whatever the overlying federal regulations are, and making sure that we're developing a vehicle that has longevity, and making sure that we're aligning ourselves with corporate goals, but also making sure that I'm aligning with what our customer needs. And in some cases, that means making sure that we're sharing our thinking with our customers and why did we choose this approach. There's a lot of conversation right now about turbo motors and whether or not they have the same sort of quality or durability, and that's not lost on us. And we didn't forget about that in the development of these new, I'll say, forced induction type systems. We have taken that very seriously, and we spend a lot of time and energy recognizing that the durability cycles need to be considered. When we think about our turbos, we actually run those, especially in the truck segment, to our commercial grade cycle, because we know that people are going to be off-road, lugging around, and they might be hauling, for example, trailers or a lot of cargo, where we might see more boost requirement more often. So we're still making those same sort of requirements that our traditional, naturally combusted motor or naturally aspirated motors were meant to achieve, and we're applying those standards and then some to these new motors as well. And that's really important, because
Because you're Toyota, it's more important than anybody else.
Our reputation has been staked on quality, dependability, and reliability. We say that all the time, and I know people start to get a little bit tired of hearing it, but it is our mantra, it's our ethos, it's what we do, and there is really no compromise in that.
So how do you make a turbo motor more reliable?
Well, a lot goes into, thank goodness, to the technology that is being developed, right? So we have new mechanisms and methods for basically predicting the stress that we'll see in there. We know that heat is kind of one of the big enemies, right? A lot goes into the remediation and making sure that we can pull that heat out, and adhering to strict standards on how hot we'll allow the turbos and for example, like the outlet gas temperature or the incoming temperature to get. So those all affect that, and we've been able to use these new modeling systems to better recreate and make sure that we have efficient fluid flow in and around the block. Just an example, and I don't know that a lot of people know this, but we're using like a 70 millimeter or so, a 3-inch pump to move the water on the L4. That's something that we would have traditionally put on a V8, but we got to move fluid, and so those are things that we're doing to remediate these issues, and we're spending a lot of time, and we have some great patents coming out on things that we have done to make sure that we bring that air into the turbo, and we smooth that so that we can make sure that we're not getting a lot of turbulence as the air enters, and trying to help again keep the system as cool as possible.
Most people don't know this, but car company, whether it's you or Mercedes, you work with suppliers.
We do.
In this case, like another example, Kia has famously made their own transmission. They wanted to do their own dual clutch transmission, and to great effect in their performance models. In this turbo setup where you're trying to, it sounds like the big goal with your turbo to make it more reliable is to lower the temperatures, which you gave me the insight of some fascinating technology. Are you developing that in-house, or is that with a supplier?
So without getting into the overall, the deep strategy, we look at commodities, we look at technologies, and we look at it from a vehicle perspective, and then a system perspective, and then a component perspective. So we look for solutions that where we have either supplier partners who are deeply embedded with us so that we can develop this concurrently, because we need to not only develop the component, but also it has to fit into our system, into our vehicle, in that environment. And so in some of these areas, we will partner with companies or suppliers who have an area of excellence in there. But in almost every single case, even with those, this is not a black box, right? These are the Toyota requirements. These are the elements that we need to beat. So it's very collaborative. And so it's very rare that we would just black box something to somebody and push it out. Usually, again, there's a lot of what our feedback is, what our requirements are. So we're saying we understand that you have certain technologies that perhaps they may have intellectual property rights that they own, and we want to leverage those intellectual property rights. And so that's why we may partner with those particular suppliers.
Okay, so with that, this is the point of the episode where I turn it around to the audience and like to solicit feedback from the audience. And what we talked about today was a lot of theory that went into not just developing, I would argue, one of Toyota's most important vehicles, but how to develop a car. And I'd like to ask the audience for some feedback on what kind of development they would want to see from Toyota moving forward. Because you've been all over the map with Toyota. You've made sedans, you've had joint ventures with one of the pioneers in the EV world. So you're the kind of guy that could probably take that and dispel some of the or I should say, disseminate some of the information to the far reaches of Toyota. So why don't you guys share with us some areas where you could see some blue sky for a company like Toyota? Do you want to hear something like that?
Always. Where the industry is going and what our customers are expecting is something that's important for us to hear, to get positive feedback, reinforces the decisions that we're making. And I hope some of the things that we're able to do is also, as being industry leaders, provide you with what that future could look like. And then we'd love to hear That's what a lot of our early concept stuff does, is what do you think about this?
And this is the kind of guy that can make it happen, because he didn't just do a joint venture with Tesla, he brought a manual transmission to a new sport version of his pickup truck. So let us know in the comments below, or via our social media, MotoManTV, all word, MotoManTV, all word, Facebook, Twitter, and Instagram. And with that, I would highly suggest you check out my full tech review of Sheldon's truck here, that frankly I couldn't have done without Sheldon, because we did a whole tech review together off camera in Hawaii, where it was misty and bugs and all that kind of stuff. Until I see you in the next episode, bis später.